Hello guys, welcome to my YouTube channel Placement Way. Today I come up with a new topic, that is what is scalability and ways to scale a system. So if you are new to this channel, please like and subscribe. So let's get into the details. When it comes to the topic scalability and ways to scale, so for any application, like as the user base grows, the system needs to scalable. That means, like as the user base grows, the system capacity needs to increase, and it must needs to serve all the user without compromising performance. So the exact definition of scalability or scaling is increasing the capacity of a particular system that can serve uh, more users without compromising the performance. So this is the exact definition. So for scaling a particular application, there are many techniques available. So regarding those techniques, I'm going to explain about them briefly, because if I explain about each and every technique in depth, then it will take more time, like at maximum of like 1 hour, like that. So in this video, I just explain briefly about each and every technique so that you can get a clear overview, and you can get what is scalability and ways to scale a particular application. So when it comes to the details, so there are multiple scaling techniques are available. So I have mentioned on the board. So here I actually considered a three-tier architecture. So that is that is I think you're already familiar with this, right? Like front end, back end, database, three-tier architecture. So why I mentioned like this means, so this that means all the people are already familiar with this three-tier architecture. So that's why I mentioned like this, so that it is easy to memorize. So that's why I have mentioned like this. And so when it comes to each and every scaling technique, first we'll go with this vertical scaling. So this vertical scaling is common for both client and backend servers. So when it comes to front end or when it comes to backend, we have these instances, right? Like servers. So we must need to deploy these front end and backend in the servers. So the first scaling technique is vertical scaling that we are considering. So when it comes to vertical scaling, so in vertical scaling, we actually increase the capacity of a particular system. That means by adding, uh, by increasing CPU power, by adding more RAM, by adding more storage. So by increasing the capacity of a system, we actually, that means this particular system will serve the user growth. That means even though if user base grows, this vertical scaling can help us to serve those users. This is one of the scaling technique, and let me go through the another scaling technique, that is horizontal scaling. So here we already saw this vertical scaling, right? When it comes to vertical scaling, if we increase the power of CPU or if we increase the RAM, ROM, there is a particular limit is there. That means for any instance or for any server, there is particular limit, right? So we can increase CPU, RAM or storage up to certain limit only. So that means this is one of the cavity in vertical scaling. So to overcome this, horizontal scaling comes into the picture. So when it comes to horizontal scaling, instead of increasing the power and these that means these resources, that means increase instead of increasing the capacity of the resources, we actually add more servers. So we add more servers. That means whenever the in vertical scaling, the whole load is on one server. But when it comes to horizontal scaling, we actually distribute the load to these servers. That means in horizontal scaling, we add more servers, right? So we distribute the load to these servers, and this will reduce the latency and it will improve the application performance. So that if there is low latency, then users also more attract to our application, right? So this is the horizontal scaling technique. And I think you got what is the difference between vertical scaling and horizontal scaling, and what is the problem that is solved in horizontal scaling that is already occurred in vertical scaling. So this is about vertical and horizontal scaling. So the next thing is load balancing. So previously we saw this horizontal scaling, right? So previously I have said we distribute the load among these servers. So who can distribute the load among these servers? For that one, we need one more component in the architecture, right? That is the load balancer. That is the load balancer. This is responsible for distributing the load among these servers. So whenever, that means any request come to our application will first reach out to load balancer, and load balancer will route the requests to these servers. So when it comes to load balancer, to distribute the load, we have multiple algorithms like the one and most what do you say? Most people already know about this algorithm like round robin scheduling, and the next thing is least connections, least response time. Like this we have many algorithms. So based on our requirement, we can use those algorithms, and we can distribute the, that means this load balancer distribute the load among these servers. So this is about the load balancer. And the next thing is CDN. So when it comes to CDN, this is the content delivery. The full form is content delivery network. So CDN means distribution of uh, that means it is a network of distributed servers across the globe. Whenever any request come to this CDN, this actually reroute the requests based on the reroute the request to the nearest edge location. So, and also when it comes to CDN, it actually catches the data, and it will reduce the latency. When it comes to CDN, we mostly use in front end, like for loading some images or some static HTML files like that. So this CDN also play a key role in scaling techniques. And I think you already know about this one, like CDN is very much helpful in like video streaming. Like if you consider Geo Hotstar, like if you watch IPL, then the live streaming will be there, right? There CDN plays a vital role. So this is the most important thing in that use case. And this is about these four scaling techniques. And let me go through the these three techniques. So the next thing is catching. So when it comes to catching, it is the process of storing a particular data that is reusable and frequently used in a particular location, where we can get the data with a very low latency. For example, Redis, and also client-side storage. And previously we have also discussed this CDN, right? This is also part of this catching technique. So this catching technique is more useful, like if we want some frequent data. And when it comes to catching, there are multiple strategies like read through, write through, catch aside, like that, and there are multiple eviction policies. So this is about this catching scaling technique. And the next thing is multi-region deployment. So if your application has users across the globe, then you must need to deploy your application worldwide, right? Then only the users across worldwide will feel low latency. That means the response time will be very low, and in that way, users will get attract. If the latency is high, then the user base growth is very low, right? So that's why multi-region deployment plays a crucial role if you want to attract users worldwide. This is about multi-region deployment. And the next thing is message queues. So when it comes to message queues, it is used for asynchronous communication between two services in an architecture. So when it comes to asynchronous communication, so let's say if we have a particular API, and in that API, if we consider just for example, the basic example I am considering is logging. So for that one, it is some asynchronous task, right? So I'm just mentioning it as example. So it is an asynchronous task, right? So for this asynchronous task, we actually do not put load on one service. Instead, uh, we actually pass the load to another service that is called consumer. So producer, consumer, message queues. So these message queues is used for asynchronous communication. So in that way, the load on this service component will reduce, and this consumer will process these requests. And when it comes to these message queue, this have some storage capacity. So that's why it can store it can store all those requests and will pass these requests to the consumer at regular intervals. And this is about the message queues. And the next important thing is database scaling techniques. So here we have vertical scaling technique. So this vertical scaling technique is same as like here I have mentioned. So by increasing the power of resources, we can achieve these vertical scaling in databases. So the second scaling technique is horizontal scaling or sharding. So this is same as like this horizontal scaling. That means by adding more database servers. So when it comes to this sharding, we actually distribute the load, distribute the data from single database to multiple database servers. So in that way, the load on one database will be reduced. Like so, let's say we have a database which is of huge size, which is of huge size. Because of this, the read and write latency is very high. So that's why we actually distribute this load to multiple database servers. Like we actually distribute the data to multiple database servers. In that way, the load will be distributed across these servers, and this will reduce the latency, and this will reduce the response time, and with this the write and read latency will be reduced. And this is about this horizontal scaling technique. And the next thing is indexing. Indexing, when it comes to database, indexing plays a key role, and it plays a crucial role. So when it comes to read requests on the database, these indexes plays a vital role. That means this will reduce the latency very drastically. And when it comes to indexing, we have different indexing like primary, clustered, and secondary indexes. And when it comes to indexing, uh, like it actually reduces the load, and also it actually uh, increases the reduces the time for retrieval process. And this is about these scaling techniques. So if you like the video, please like, share, and subscribe. For more informative videos, please like and subscribe. So that's it, guys. Thank you. Bye bye.